8.2 distribution of the sample proportion. Okay. All right, so here we have a sample size n, and the sample proportion, that is denoted as p hat. So a little house top on top of the p there, we read that as hat. Okay? And that is given by x divided by n, where x is the number in our sample, and n is our population number there, okay, the sample size and those things. So we can always use our sample proportion, p hat, to estimate the population proportion. All right, so here we have this Harris poll. They did 1,200 adults. 552 indicated they plan to work while on vacation. So what is our sample proportion? Well, we just simply take the 552 divided by 1,200, and we get 0.46. And so that means that there is a 0.46 or 46% of Americans will work on vacation. Okay, so just a simple there of x over n. Okay. All right, so now let's start looking at what this means overall. Okay, so here we have 76% of Americans believe that the state of moral values is getting worse in the U.S. And so we want to look at the sample proportion for different sample sizes. All right, so if we go through and look at all those pieces here, we end up creating the following histograms. So here's our first one with sample size n. We would end up with this kind of shape to our proportion. Okay, and then if we move to 25, we have this piece as well. And then finally, what if n is 60? So notice there that as we are increasing in size, so let's go back through those again there. So each one of those, as we increased in size, they got closer and closer to that bell shape. Okay, and so that's going to happen. So for the shape of our pieces, as the size of the sample increases, the shape of our distribution becomes approximately normal. All right, we like that because then we can use any of our normal probability pieces for that. All right, so the center here, the mean of the distribution of the sample proportions equals the population proportion. So then that we know that we're going to have some equality. And then finally, the spread, the standard deviation of the distribution decreases as the sample size increases. Okay. All right, so what does that mean formula-wise with those? Well, first of all, for it to be approximately normal, we must have that this formula is greater than 10, greater than or equal to 10. That is n times p times 1 minus p. So we always need to check that. If it's less than 10, then it doesn't really fit within those pieces. But as long as it's greater than 10, when we plug in our n times the p times 1 minus p, if that is greater than or equal to 10, then we know that we're going to be approximately normal. Now the mean of our sampling distribution here will equal the proportion of the population. So the mean of p hat will equal p. And then finally, the standard deviation, we said it would get smaller, so it's going to fall within this formula. So the standard deviation of p hat is going to equal the square root of p times 1 minus p divided by n. All of that being underneath the square root when we're looking at that, okay? So again, those are formulas that we're going to need moving forward. Okay. All right, so going back to the state of moral values here, let's look at the stuff for this. So we want to describe the sampling distribution. Okay. All right, so first we want to check our sizes. We always want to be less than 5% of the population size. So if n is 60, we're talking about the United States. 60 is obviously a super small amount of 300 million people. So we're well below that piece. Okay. And then we need to check and see if our formula there, n times p times 1 minus p, if that is greater than or equal to 10. And so we know that our n is 60, our p is the 0.76 that we talked about previously, and then 1 minus 0.76. We multiply all that together, we get 10.944, which is greater than 10. So we know that we're going to be normal. Well, Then we can talk about our mean. And so since our p is 0.76, that means the mu of p hat is also 0.76. Okay? All right, so then we move on to our standard deviation here. And so we plug into our formula. So all of that goes in the calculator. So when we're doing those pieces here, we want to go into our square root. So it's second x squared here. And then we would do 0.76, just open parentheses, 1 minus 0.76, close them, and then divided by n is 60, and press enter. And so we get 0.055 when we're looking for that. Okay? And so we can see those pieces there. All right, now let's start looking at computing some probabilities using this information. Okay? All right, so here we say that 15% of all Americans have hearing trouble. In a random sample of 120 Americans, what is the probability at most 12% have a hearing problem? Okay? All right, so again, we need to check our sizes. 120, we're talking about all Americans, so we're definitely less than the 5%. We plug into our n times p times 1 minus p, we get 15.3. That is greater than or equal to 10, so we're good. We know this is going to be approximately normal, so we need to check those things. All right, so our mu is 0.15 because it is p, that's 15%. And then our standard deviation here is the square root of 0.15 and then 1 minus 0.15 divided by 120. They don't come up with any numbers from that, so let's go ahead and just kind of get an approximation so that we can look at a couple of things later on. Okay, so we're going to do the square root there, 0.15 times 1 minus 0.15 divided by 120. And we get 0.03259, okay, for that. So in the computer, they're probably going to want this answer over here, and so we round accordingly for those, okay? All right, so we want to know the probability that the sample proportion is at most 12% or 0.12. So that means that we are doing the probability here of p being less than or equal to 0.12. Now, we know that this is going to be normal, right? So we can use our normal distribution for these pieces. Okay? Now, they go through and do this by hand. We're going to let the calculator work for us. They go through and find the z-scores in all of those pieces. Okay? And so they come up with a couple of answers. One, if they're doing it by hand, they came up with this answer. But if they're doing it by technology, they get this answer, which are very close. It's not a problem. So let's look at how our calculator will do those same things. Okay? Now I do want to remember this number up here because we're going to need this number. That's our standard deviation. So you may want to write that down. I'm going to write it over here. I'm going to say my standard deviation here is 0.0326. I'm going to round up there to 3 decimal places or 4 decimal places. Okay. All right. So we're going to do our second VARs. We're going to do normal CDF because we're doing less than. So since it's less than, we have our -1E99. Our upper is going to be 0.12 because that's our p-value there. We can see that from those pieces. Now our mean we know is 0.15, right? We saw that earlier. And now our standard deviation is 0.0326. Okay? Using that. Now, technically you can write in the whole mean just like they did a while ago with the square root stuff if you wanted to be more exact, because I have a rounded answer. But if you're going to round, make sure you go out probably at least 4 decimal places or even further. We could have gone further on that. Okay. And then we press enter, and you can see there that we get the 0.1787. So we're very close as well to what they got. Actually, one of the answers that they have here. Okay. All right, so we can use those same things because we're talking about it being normal. All right, so kind of an interpretation there that with a sample of 120, well, the probability of having at most 12% is approximately 0.18. So that means 18 out of the 100 samples of size 120 would result in at most 12% of those samples with a population proportion with hearing trouble is 0.15. Okay. All right. Now let's suppose in part B here that we have the 120 who regularly listen to music results in 26 having hearing trouble. So we're looking at 120 samples, 26 of those samples having hearing trouble. What might you conclude? Okay. All right, so our sample proportion is 26 out of the 120. So that's a 0.217 for our proportion. Okay. And so we want to know if this is unusual compared to the 0.15 for those pieces. Okay. All right, so we want to compute if it's greater than how much is greater than 0.217, right, for those, and see if that is unusual. All right, so we want to look for those things. Now, again, they're doing it by hand for these pieces, and we would be able to get these this data here for these. So let's look and remember how to do this in the calculator. So since it says greater than, so again, we're looking here at greater than, that means we need to do 1 minus the probability here with this. And so second VARs, normal CDF on those, okay? All right, so this time our P is 0.217, okay? Now these two things aren't changing because we're still dealing with the same numbers, right? We're still dealing with 0.15, we're still dealing with the standard deviation of 120 because we're still have the same piece there, okay? And so when we look back at our problem, so their answer as well. So they got 0.197 or also 0.199, and that is also 0.199, sorry, which is what we got as well, okay? All right, and so then there's just interpreting those pieces, okay? And because that number is so low, it's less than 5%, 0.05, it would be unusual to create that much, okay? And so that, again, is just the conclusions from those. All right, so that is what you need for 8.2.